Okay, welcome to this video where we're going to have a look at going through a practice paper with all the topics that are on the advanced information list for paper 1. Now this particular paper here, it's around about 80 marks, but it's not bang on, but it's very, very close to being 80 marks. And what we're going to do, we're going to go through this paper pretty quickly, because obviously this is aimed at being done the last night before your paper 1 exam. So I'm going to go through this relatively quick. I'm going to try and explain every question in as much depth as I can, but I am going to be rushing through the questions, obviously, because I know that you've got all this night that you're going to be planning and wanting to do your revision. I don't want it to all to be taken up with just watching this video. So I'm going to go through it quite quick. So if you don't like quick explanations, this video might not be for you, okay? But just fair warning, I am going to go pretty quick through these questions. So if you're ready to get through this paper, then stick with me, but otherwise, let's get started. Okay, so looking at our first question, and we have product of prime factors. So very important that we get the first two branches right here. So I'm looking for two numbers that multiply to make 56. I'm just going to go straight off the question. So I know it's even, so I'm going to divide it by 2. So let's go for 2, and it's 2 times 28 that makes 56. I'm going to circle the 2 as that's prime, and then we're going to go 2 and 14. Circle the 2. And then that's going to be 2 and 7, and 7's prime as well, so our prime factor tree has finished. I've got two ways of writing my answer. I can write it as 2 times 2 times 2 times 7, and I can write those in any order that I want, or I can simplify the 3 2's there and write that as 2 cubed. So I'm going to write my final answer as 2 cubed multiplied by 7. And there we go. Quickly go back, double check those first branches are okay. So 2 times 28. As long as you're happy that that makes 56, chances are you've probably got the rest of the tree correct. So always just go back, just quickly double check it, make sure you haven't missed anything there while you are sort of rushing through these earlier questions. Okay, so on to the next one. So we've got an inequality, a linear inequality. So we're going to treat that inequality like an equal sign. So I want all the n's to be on one side here. So I'm going to minus 11n from both sides so that the n's are on the left. So we have 3n. And that's going to be bigger than 6. So there we go, just like an equation. Now we divide by 3, and we divide 6 by 3, we get n is going to be bigger than 2. So n is greater than 2, and that is our final answer for solving that inequality. On the next part, we have drawing it on a line graph. So for here, we need to have a look at what's in the middle. It's not just x in the middle, so we need to subtract 3, and because we need to subtract 3, we need to do that from both sides. So if we amend this inequality, negative 2 take away 3 is negative 5. We've just got x in the middle now. And we have a less than or equal to symbol there. And 4 take away 3 is 1. So we've got negative 5 and 1 that we need to put our circles above. So negative 5 and 1. It's a joint inequality, so we do join these together. And our right symbol there has the extra line on, so we colour that symbol in as well. So there we go, that's drawing a linear inequality on a line graph. Okay, on to our next question. Right, so for this one here, we are adding fractions where we have mixed numbers. So to add these together, we need to make them improper. So the big times the bottom at the top. So 2 times 7 is 14, add the 1 is 15, so 15 over 7. Add 1 times 4, add the 1 is 5, so 5 over 4. Now we need to make a common denominator, so we'll times the left by 4 and the right by 7. So on the top there, just be very careful here that you don't make a mistake, because obviously you don't want to lose marks on these earlier questions, particularly when you're confident with this topic. So timesing that by 4, we get, well, double it is 30, so 60 over, and that's 28, 4 times 7, add 5 times 7 is 35, and 4 times 7 is obviously 28, that's why we did it on the left as well. So adding those two together, you get 95 over 28. Now this question here doesn't say to write it as a mixed number or to simplify it or anything like that, so we can leave it as 95 over 28. Of course, you wouldn't be wrong to write it as a mixed number and try and simplify if it does simplify, but you're not going to gain any marks for that because it doesn't ask you to, so it's fine to leave your answer there as 95 over 28. Now I've already spotted this next question does say to write your answer as a mixed number in its simplest form. So we're going to do a division. Again, we're going to make that first mixed number there top heavy, so we're going to make that an improper fraction. So the 1 times the 5 add the 1 is 6 over 5. We're going to divide that by 3 over 4, so we're going to keep flip change, so times that by 4 over 3. 6 times 4 is 24, and 5 times 3 is 15. Now this question does say to give it as a mixed number in its simplest form. So if we write that as a mixed number, so 15 fits into 24 once, and the remainder there is 9, so you get 9 over 15, and you'll probably hopefully spot there that fraction there, 9 over 15, simplifies. They both divide by 3, so that'd be 1 and 3 over 5 when we divide them. So my answer would be 1 and 3 over 5. Of course, what you could have done is you could have simplified 24 over 15 first. You could have divided them both by 3, then turned it into a mixed number, but that's fine. If you simplified it first, you've got 8 over 5, and then of course you'd get 1 and 3 over 5 for your answer there anyway. So there we go, there is fraction calculations. We've got a standard form conversion here, so that is a 0 point number, so it's going to be a negative power. We need to hop the decimal 1, 2, 3 jumps, so 5.49 times 10 to the power of negative 3. On to our next one. We've got this bracket squared, so rather than trying to square what's on the inside, I'm going to write 2 brackets. So we have 8 times 10 to the power of 3, and that's getting multiplied by another 8 times 10 to the power of 3, and that's hopefully something you recognise a little bit easier. So you do 8 times 8, which is 64, and then times 10 to the power of, and when we times these two 10s together, we get the power of 6. Now don't get that confused with double brackets there. That is a number, that's 8,000 times 8,000. So all we're doing is timesing the first numbers together like you would if you were doing 8,000 times 8,000, getting that 64 and adding all the zeros on essentially is what we're doing. Now that's not in standard form, so we have to make the number 1 jump smaller, so 6.4, make sure it's between 1 and 10. And because we've made the number smaller, we balance that out by making the power bigger, so it becomes 10 to the power of 7. So 6.4 times 10 to the power of 7. On to our next one, we've got adding together standard form. There are no tricks for this, so you just have to convert them into ordinary numbers, add them together, and then because it says to write it in standard form, we're going to have to convert it back as well. So 7.6 times 10 to the power of 5 would be 1, 2, 3, 4, 5 jumps. Adding in all your zeros, that's 760,000. For the 8.7, that would be 8 and 7, 1, 2, 3, 4, so we'd have 3 zeros after that. Now we want to line them up using normal column addition, so I'm going to start from the end number. I'll put the 0, 0, 0, 7 and 8. We're going to add those together, so that's 0, 0, 0, 7, that adds up to 14, so carry the 1 and then 8. So hopping the decimal back in, let's swap colour because there's a lot of lines here. 1, 2, 3, 4, 5. So it's going to be to the power of 5. So it's 8.47 times 10 to the power of 5. And there we go, there's our standard form calculations done. On to the next one. Okay, so we have a polygon problem. So it says here below, it's a regular octagon. ADJ is a straight line, so that's this line here, just drawing along there. And it says BAD is equal to angle CDA. That's very nice because that's been labelled for us there as well. We've got those angle markings. Show that angle CDJ is 135. So where's that? CDJ, that's the angle just here. And we want to show that that is 135. Now this is important because when it says to show that it's 135, we have to forget that it's actually told us that. So we're going to try and find this angle out. Imagine it just said angle X here, and it says find the value of X. Now, it's nice because as long as we get 135, we know we've shown it, but we need to forget that it's told us that, because if we use that at all, we're not going to show it. We'll be using that to prove other things. So the first things first, it says it's an octagon. So if it says it's an octagon, we want to work out the interior angles, and you'll see actually the shape that it's made at the top, these two interior angles here, will be whatever we get. So if we've got 8 sides, we'd do 8 take away 6, 8 take away 2, sorry, which is 6. And that's how many triangles it's made up of. So 6 times 180. And take your time to work that out. Obviously, it's a non-calculator paper. You might know that off your top of your head. If you don't, just do your working out just below. So 180 times 6, 6 times 0, 6 times 8 is 48. 6 times 1 is 6, so that adds up to 10, so it's 1080. So that's 1080, and it's got 8 sides, so we want to divide it by 8. Now just a side note here, because I actually know that the interior angle of an octagon is 135. Okay, but if I just write 135, I'm actually risking not getting any marks here, because the question might think that I've just read the 135 in the question. So I do want to show my working, because I might get 1 to 2 marks for this, so I'm going to make sure I show it all. So 8 goes into 10, once, remainder 2. It goes into 28, well, 8, 16, 24, so 3 times, remainder 4. It goes into 45 times, so there we go. There, I've shown all my working out, and now I know that both these angles here are 135. So how's that going to help me? Well, this shape here is a quadrilateral. So it's also told us that those 2 angles at the bottom are equal. So if I know the total of all these angles is 360, as it's a quadrilateral, I can take away the total of the 235s. So these 2 here, they add up to, at the moment, well, add them both together, 270. So if we take away 270, that leaves us with 90 degrees. Okay, take your time to work that out if you weren't too sure on that, and we'll divide that by 2, as both those angles are equal. So both those angles there are 45 degrees. So that's 45, that's 45. And now, because we know that that was a straight line, which we were told in the question, this one here, to work out that value of x, our final bit of working out would be 180 degrees, take away 45, which is 135 degrees. So there we go. We've found that the angle is 135. We've shown all the correct proof there, and that's very important with that language where it says show that angle CDJ equals 135. Okay, right, on to the next one. Okay, so we have a reverse mean. So for this one here, it says that there are 10 boys and 20 girls in a class, and the class has a test. The mean mark for all the class is 60, and the mean mark for the girls is 54. Work out the mean for the boys. So when it tells us the mean, we take how many students or how many people or things it's related to and multiply them together. So for that mean of 60, we want to do 60 multiplied by the total amount of students, because that's for all the class. So it's 30 students, so 60 times 30. So to work that out, 6 times 3 is 18, add the 2 zeros, 1,800. For the next one, the mean for the girls is 54. So 54 is the mean. There are 20 girls, so 54 times 20. And 54 times 10 would be 540, or you could double it, which is 108, and add a 0. You could do that as well. So 108 plus a 0, 1080. Okay, so to work out the total for the boys, we want to take those away from one another, and that would give us 720. And then it tells us in the question there are 10 boys, so we would do 720 divided by 10, and that is equal to 72. So the mean mark for the boys must be 72. So that's what we'd write down there on our dotted line. Obviously, as we're going through this, you can see how many marks you get for this question. So I'm not going to talk too much about how many marks you get. As I said at the start, this is just going through some questions nice and quick, so you get a nice coverage of lots of different topics. Right, so we have a quadratic graph. Now the chances are, with a graph like this, we are going to be asked about roots and turning points. I probably should have said at the start, I haven't actually seen this paper yet, so I'm kind of seeing these first time along with you, just to get a kind of feeling of how I would be thinking if I was doing these in the exam. So there we go, let's have a look. So it says write down the coordinates of the turning point. Okay, so for the turning point, we are going to find the point at which it stops going down and starts going up, or obviously the other way around, depending on which way we look at it. So that turning point is right down here at the bottom of the curve. So I just want to be very careful to read that. So 1 is the x-coordinate, so I'll put 1 there. And the y-coordinate, it looks like, for me, it's bang on -3. So there we go, 1 and -3 would be the coordinate of our turning point. So obviously do that in pencil, because we want to get rid of that just in case it interferes with any other working out. So for this next bit, write down estimates for the roots where f of x equals 0. So that's another way of phrasing it rather than saying the roots of the curve or the quadratic or the equation if it's given to us. So where a function or where a graph equals 0 is ground level. So it's along the x-axis just here. So that is ground level where it equals 0. So we have one point there and another point there. And you want to read that nice and carefully. So that's 2 points, and it's very difficult to see on mine. Let's just see if I can count it perfectly. So 2.1, 2, 3, 4, 5, 6, 7. Looks like 2.7. It's kind of half in between. So 2.7 or 2.8 would be fine. So 2.7 I'm going to say for one. And for the other root, let's have a look. minus, it hasn't quite hit -1, minus 0.1, 2, 3, 4, 5, 6, 7, 8. There we go. So, and minus 1.8. There we go. And obviously, if it can be 0.1 out, particularly on this sort of graph here, which is quite difficult to read it. And the line is actually kind of almost going past the point there. But as I said, it says estimates. So we just need to get it as best and as accurate as we can. Right, so for the next one, use the graph to find an estimate for when f of 1.5. Obviously, you can see just above that f of x has been replaced by 1.5. So it means it wants to substitute 1.5 into that function there. So when x is 1.5, that's obviously halfway between 1 and 2, that's just there. So where is the graph, or what's the value of y when x is 1.5? Well, if we go down very carefully with the ruler and then go across again super carefully, that looks like minus 2.8. It's just above the -3, and those going in 0.2s there. So that's minus 2.8, and that's the value of y when we have f of 1.5. So we go, there's lots of things, roots and turning points of quadratics, and also that little bit of function work there as well. Okay, so question 8. Right, we have what looks like it's going to be a probability tree. So Sally plays 2 games against Martin. Each game Sally can win, draw, or lose. In each game they play, the probability that Sally will win is 0.3. The probability she'll draw is 0.1, but it's not told us the probability that she'll lose. Work out the probability she'll win exactly 1 game, so one of the 2 games. Okay, so we need to draw a probability tree. You can obviously do this without a probability tree, but I think it's probably a bit easier to visualize if we draw a probability tree. So win, draw, and lose. So the probability of a win, let's just have a look, was 0.3. The draw was 0.1. That adds up to 0.4, so 0.6 for a loss. So that's the first game. You can label that first game if you want. And then we're going to look at the second game. So we've got another 3 branches, and these are always really messy when you've got to draw 3 branches. So let's label that. We'll try and keep it as small as we can. Win, draw, lose. Win, draw, lose. And then win, draw, lose. Right, so we just about fit that all in. Now the probabilities don't change between the games, so they're going to be replicated on these branches. So 0.3, 0.1, 0.6, and then just repeat that for all of them as, there we go, nothing changes between these events. So 0.3, 0.1, 0.6. I'm kind of going over my dotted line there, so I need to be a little bit careful. Okay, so which branches here do we want for exactly 1 game? Well, we could win, but then we'd have to either draw or lose. So this branch and this branch. We could draw, but then we'd have to win. That'd give us exactly 1. Or we could lose, and then again we'd have to win to get exactly 1. So we've got 4 branches there that we need. So we have this one, 0.3 times 0.1. Careful with that, which is 0.03. We've got 0.3 times 0.6, which is 0.18. And we have 0.1 times 0.3, which is another 0.03, and the final one down here, 0.6 times 0.3. Okay, that's not too bad actually, because we had the same 2 calculations twice. It was actually quite quick to work them out. Okay, so we've got 4 numbers there, and when we have more than 1 probability, we need to add them all together. So I'm just going to put a plus down here. I'm going to add them together. You can obviously rewrite those, make it nice and clear with your column addition. I'm going to do it in my head. So 0.18 add 0.18 is 0.36. Add the 3 is 0.39. Add the other 3 is 0.42. So that adds up to 0.42. I'm pretty happy with that. Confident I've done that correctly in my head. So 0.42 would be your final answer. Okay, so there we go. There's our probability tree. Okay, so we have some volume, we've got some fractions, and we've got some ratio. Right, okay, so there's a lot going on in this question. So we've got a fish tank in the shape of a cuboid. The dimensions are 50 by 32 by 20. 3/4 is full of water and sand. The ratio of water to sand is 5:1. Work out the number of litres. Okay, litres as well, litres of water in the tank. So it's mentioned litres, so straight away I can see it's in centimetres. So I'm going to have to convert it. So 1,000 centimetres cubed is equal to 1 litre. So straight away I'm going to write that down, almost writing down the complete wrong word there. Let's get rid of that. There we go. So 1 litre. Right, so working out the volume then, how could we approach this? Well, we could work out the volume of the whole cuboid, which would be 50 times 32 times 20. We could then do 3/4 of that to get the water and sand, and then split it in the ratio 5:1. That seems like it's a logical way to do it. Is there another way though? Because actually that's going to be quite a big number. We're not using a calculator. What we could do actually is we could work out 3/4 of the height. And that'll tell us the height of the water and sand, and split that in the ratio 5:1 and get the height of the water. I think that's going to be quicker. So if we work out 3/4 of 32, so 3/4 of 32, divide by 4 would give us 8, times by 3 is 24. So the height of the fish tank is 24, oh, sorry, the height of the water there, here to here, is 24. If we split that in the ratio 5:1, let's have a look. So 24 in the ratio 5:1, so divide by 6, sorry, 24, written 25. There you go, all these little things that you can make mistakes on when you're kind of rushing through an exam, you're worried about the time. So 24 divided by 6 is 4. And then we have the ratio 5:1, and that's a good point really that I'm kind of thinking about there. When you do make these little mistakes in the exam, don't let it stress you out, kind of just laugh it off and move on. It's kind of the best way just to keep yourself focused. So 5 times 4 is 20, and 1 times 4 is 4. So there we go, so it's 20:4. So the height of the sand, we've just worked out, is 4, and the height of the water is 20. So if we just think about that actual cuboid there of water, we know the width along the bottom is 50, the depth going backwards is 20, and the height is 20. So actually we have a cuboid. We could work out the volume of the water straight away there, and we could just do 20 times 20 times 50. So I'll highlight that, 20 times the 20, which is the height, times the 50, which is the base. Let's write that down, 20 times 20 times 50. There we go, that's not too bad. So 2 times 2 times 5 is 4 times 5, which is 20. And then 3 zeros, so 1, 2, 3. So that's 20,000 centimetres cubed. So to turn that into litres, there's 1,000 centimetres cubed in every litre. So we want to divide that by 1,000, and that would be 3 jumps in, so that would be 20 litres. There we go, so our answer is 20 litres. Now that to me seems a little bit easier than having to have done the original volume, which would be 20 times 32 times 50, then having to do 3/4 of it, and then splitting that in the ratio 5:1, and then still converting that back into litres. So I think that was probably the easier method there, just changing the height, but obviously both would have been absolutely fine. So there we go, final answer, 20 litres. There we go. So on to our next one. The total surface area of a cube is 294. Okay, I'm going to definitely, I don't like that there's not a diagram, so I'm just going to draw that quickly. So there's my cube. The surface area is 294. Okay, so that is the total of 1, 2, 3, 4, 5, 6 surfaces. And all of those surfaces are the same. So if I want to work out the volume of the cube, let's think about working out the area of each face. So I'd have to do 294 and divide that by the 6 faces. So 6 doesn't go into 2. So 6 into 29, 6, 12, 18, 24 goes in 4 times with a remainder of 5. And then 6 into 54 goes 9 times. So that's absolutely perfect because that gives us an area of 49 for each face of the, each square on the cube. So to get the side length of the cube, so we can get the volume, we'd want to think what 2 numbers times to make 49 if that's the area. So we could just do the square root, or we could just do that in your head. So that's 7. So each side must be 7 because that would give each area, each face an area of 49. So the depth must be 7 as well. So to work out the volume, you times them all together. 7 times 7 times 7. 7 times 7 is 49. And again, you might, this is one of the ones you might know off the top of your head. It's a bit of a weird one. But let's just work that out. So actually I've got to do 49 multiplied by 7. 9 times 7, 63. 4 times 7, 7, 14, 20, 28, plus the 6 is 34. So that is 343. It's already given us the units there, so we just need to write the number, 343, and that's the volume of the cube. There we go, there's a bit of surface area and volume with cubes involved. Okay, so we've got some fractional and negative indices. So the first one's okay. Whenever there is a fraction involved in a power, the bottom number is the root and the top number is the normal power. So this is 64 to the power of 1 over 2. So 1's the normal power, 2 is the root. So it's just the square root of 64, and that's 8. So there we go, there's our answer for that one, nice and quick. This one has more involved. We have a negative power, which is the reciprocal. We've got a 3 on the bottom, which is a cube root, and a 2 on the top, which means squared. So we've got quite a lot going on in this question. Now, I would pick a particular order with this. So I would start by just making sure I get 1 mark, and that's the easy mark, which is just flipping it over. So I'll do the reciprocal, 125 over 8. Now I'll worry about the denominator. I'd always try and make the numbers smaller before trying to make them bigger, because I don't want to square them and then try and find the cube roots. So if I do the cube root next, so I'm just going to write that in as well, to show that I know what I'm doing. I want to make sure I get as many marks as I can. So the cube root of 125 is 5, and the cube root of 8 is 2. Now I want to square them both to finish this off. So the square of 5 is 25, the square of 2 is 4. There we go, and I can leave that as 25 over 4. I don't have to worry about trying to make that into a mixed number or anything like that. It's just 25 over 4, that's my final answer. Okay, so that's negative and fractional indices. All these questions. Okay, so we have ratios as fractions. These are always a little bit annoying to work out. So let's have a look. They're not too bad, but I would use a probability style method for this as well. So it says white shapes and black shapes. So using a game, some are circles, some are squares. White to black shapes are in the ratio 3 to 7. Then we have white circles to white squares, 4 to 5, and black circles to black squares, 2 to 5. Work out what fraction of all the shapes are circles. So I'm going to split this off into white shapes and black shapes to start with. And I'm going to turn that ratio into a fraction. So we have 3 and 7, so that's 3 out of 10 and 7 out of 10. For the white shapes, it says they are, circles and squares. And that is 4 and 5, so it's 4 out of 9 and 5 out of 9. The other one for circles and, let's definitely get rid of that, we don't want to have squares going up. Now we've done circles going up, circles and squares, and that is 2 out of 7 and 5 out of 7. There we go, so 2 and 5, so that's definitely out of 7. So what fraction of all the shapes are circles? So we want to know the white circles, which is up this route, and let's swap colour for this one. We want the black circles as well, which would be that route. And then we've got those two, we'll add them together just like a probability tree. So 3 over 10 times 4 over 9. I may as well write the working out down for this. So 3 over 10 times 4 over 9, because on these types of questions, that bit of working out there gets us a mark, particularly when we write the next one. So 3 times 4 is 12, 10 times 9 is 90, and there's my final fraction. And the next one, we have 7 over 10 times 2 over 7. So 7 times 2 is 14. 10 times 7 is 70. 70 on the bottom. Okay, so for this one here, to add them together, it's going to be awkward because we've got different denominators. Now, little trick for this one, let's not do 90 times 70 and try and make some ridiculous denominator. Let's see if they simplify first. So 12 over 70, the top and bottom divide by 3. Actually divide by 6, but oh well, we've said 3 now, so let's go 4 over 30, and they divide by 2, so that goes to 2 over 15. Okay, that's as simple as it can go. 14 over 70, that's a little bit nicer. They both divide by 7, so that's 2 over 10. Actually, they both divide by 14, there we go. So that is 1 over 5. So we have two fractions, we have 2 over 15 and 1 over 5, and they're the two we want to add together. So let's write that down here, 2 over 15 and 1 over 5. So that's much nicer now because I can make a common denominator of 15 by changing the 1/5. So that'd be 2 over 15 add, and if we times that by 3, that'd be 3 over 15. So that's much nicer to add together. Now we have 5 over 15. That's a very interesting one because actually that does simplify. So divide the top and bottom by 5 and you would get 1 over 3. So actually my final answer is 1/3. So 1/3 is my final answer. Let's just have a quick look. Work out what fraction of all the shapes are circles. So actually we didn't need to simplify it. 5 over 15 would have been fine, or any other sort of equivalent fraction there, but we've got the simplest version, so I'm happy with that. 1/3 is our final answer. Okay, so this question here, we have some density involved. So we have a rectangular frame made out of 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. So that's basically almost looking at density. It's 1.5 kilograms for every meter. So work out the total weight of the metal in the frame. So let's have a think. Well, we know it's a rectangular frame, so this is going to be 5 over here. This is 12 at the top. We just need to get the length of that diagonal. So to get the length of that diagonal, we'd use Pythagoras theorem. So 5 squared add 12 squared, and that is 25 add 144, which is 169. And then we're going to have to square root that. So we square root 169. And the square root of 169 is 13. It's one of those square numbers that you just need to know for the non-calculator paper. Just obviously knowing it's that one that's bigger than 12. You're not going to be asked to square root 169 and get the decimal version, so use a bit of logic there as well. Okay, so there's all our numbers. Right, so we need to add those all together. So 5 add 5, add 12, add 12, add the 13. That's 10 plus 12 is 22. Obviously, you can take your time, add these together. There we go, that adds up to 47. Okay, so 47 metres in total. Now, every one of those metres, it says, is 1.5 kilograms. So we would do 47 metres multiplied by 1.5. You've got two ways of doing that. I know that add timesing by 1.5 just adds 50% on. Thinking about like a calculator multiplier method. So you could work out 50% and add it on, or you just hop the decimal out. So 47 times 15. 5 times 7 is 35, carry the 3. 5 times 4 is 20, add the 3 is 23. Put your placeholder in, 1 times 7, 1 times 4, add it all up. 5, 0, carry the 1, 7. Hop your decimal back in, 70.5. So that's going to be 70.5 kilograms. The kilograms is already on the dotted line, so we just need to write that 70.5. So there we go, a little bit of a different question there. That's a Pythagoras, non-calculator Pythagoras. So, cumulative frequency. Let's have a look. Now, with cumulative frequency, we need to remember to plot the endpoints and just have a look. Does it say cumulative frequency? Yes, it does. We don't need to worry about adding those up. And always just highlight this starting number here. So that starting number is where I have to start the cumulative frequency graph from, not from the origin, unless that was 0 there. So I need to plot all of those. I'm quite happy I don't have to add those all up. It's a lot quicker. It's a bit awkward because I have to scroll up and down, but the cumulative frequency is 5 on the 40 mark. So on the 40, up to 5, I'm going to put a little cross down here on the 20 where I need to start from 2, just to make sure I don't join up to the origin. Let's have a look. It goes up in 20, so I can speed this up a little bit. So 25 and 35. So 25 is here. 35, another 20 along there. Then we have 38 and 40. Okay, that's a bit awkward. 38 is there. 40 right at the top. There we go. So there's my cumulative frequency graph. I need to join that up freehand with a nice smooth curve. Take your time. Make sure you go through every point. Try and do it perfectly. There we go. So I've gone through every point. Okay, so use your graph to find an estimate for the interquartile range. So for the interquartile range, I need to find the upper and lower quartile. So it's out of 40 in total. So a quarter of 40 is 10, so I'll just divide it by 4. So I'm going to go 10 up from the bottom, 10 down from the top. So 10 up from the bottom would get me to 10. So I'll go along from 10 with a ruler and a pencil. And I go down, I read that number perfectly. So that for me comes out as, I was about to write 43 there. Be very careful because that is 50 in the middle. So each little dot goes up in 2s. So that is actually 42, 46. So that's 46. On the other one, I need to go 10 down from the top. So I'll go along from 30. You have to be very careful here that I go down. I think it's just on that line there for me. There we go. Again, that goes up 3 squares. So that's 246. That's 66. Everyone's is going to be slightly different here, obviously, because you can freehand draw your curve ever so slightly different. So for me, it'd be 66 take away 46. So my interquartile range would be 20. And again, that is why it says find an estimate, because you are just estimating from the graph. Everyone's curve is going to be slightly different. But there we go, that's the end of that question. So a couple of points there. Make sure you join up to the start of the table, that yellow number that I've circled. Make sure if it doesn't give you the cumulative frequency, you add those together, but this one did. And then interquartile range, make sure you find a quarter of the total cumulative frequency here. And then we'll go up and down from the bottom by that amount to find those quartiles. So that was our lower quartile. That was our upper quartile. Interquartile range, you find the distance between them. Okay, so there is cumulative frequency. Okay, we've got some surds. So for this one here, not a particularly difficult one. We've just got to multiply this bracket out. So you multiply them just like normal times tables, just the numbers under the surds. So root 5 times root 8 is root 40. 5 times 8. Add root 5 times root 18, which is root 90. There we go. So you can already see that if you know your surds well, 4 and 9 go into those. So root 40 can be written as the square root of 4 times the square root of 10. Root 90 can be written as the square root of 9 times the square root of 10. So these are both going to have a root 10 in there. And actually, I should have read the question a bit longer there because it does say it can be written as a root 10. So the square root of 4 is 2, so that's 2 root 10. The square root of 9 is 3, so 3 root 10. And when we add those together, you get 5 root 10. So is my answer 5 root 10? No, it says a equals, it does say find the value of a, so a equals 5. There we go. So a is equal to 5. Okay, so exact values of trigonometry. So with exact values of trigonometry, let's just have a look. It's got we've got tan 30 and sine 60. Good. So I only have to draw one of my triangles here, whichever method you've learned. I like to use the trigonometric triangles for this. So this angle is 60 and 30. That is 2, 1, and root 3, or 1, 2, root 3. Okay, obviously I'll link all the videos for this if you're not sure on how to create that. I'll link them all in the description so you've got them all there if you need to revise any of these. So for tan 30, I'm going to write down my SOHCAHTOA triangle, and for sine 60, SOH, you can write down cos as well if you want, if you like to write them all in order. So for tan 30, it's opposite over adjacent. So for the 30, let's draw on this. So opposite is 1, the adjacent is root 3. So for tan 30, that is 1 over root 3. You can label that as well if you want, just so you don't forget that that's the tan 30 you've just worked out. Sine 60 is opposite over hypotenuse. So opposite is root 3, hypotenuse is 2. So it's root 3 over 2. And it wants us to times them together. So we're going to times them together. So let's go about doing that. So 1 times root 3 on the top would be 1 root 3. I am going to write that as 1 root 3 because I can already see what's about to happen. And then root 3 times 2 is 2 root 3. So in this question here, we have a root 3 on the top and the bottom. We need to cancel those out. So I don't want to forget that when I divide the top by root 3, I am just left with 1. Now, if you hadn't written that, it's still fine, but you might forget to put that 1 in there. So sometimes I just like to include it. But as long as you're happy with that, when you divide the top and bottom by root 3, you get 1 on the top and 2 on the bottom. So our final answer is 1/2 for that question. There we go. And there's looking at exact trigonometric values. Okay, so we have a recurring decimal for our next question. So we've got 1 recurring decimal, so that's going to be quite nice. And it does actually tell us to show that it's going to be 13 over 30. It does say prove that. Now you've got to be very careful when it says prove that. So I'll show you why. So we've got to use obviously our algebra method anyway. So we get x equals 0.43. We've got 1 recurring decimal, so we're only going to times by 10. So 10x, again, there are other ways of doing this, but this is just a quick way that I use. So 4 point, it's only the 3 that's recurring, so 3, 3, and then the 3's line up. When I take them away, I only have to worry about what's before those recurring 3's there. So 10x take away x is 9x, and 0.4 taken away, or I should say 4.3 take away 0.4 is 3.9. Obviously that can get quite complicated sometimes, so just write it down to the side. 4.3 take away 0.4, and then obviously do your borrowing like that, and there we go. So 13 take away 4 is 9, 3 take away 0 is 3, so 3.9. Now I turn it straight into a fraction, so x is equal to 3.9 over 9. And once you get to this point, make sure you've written it using algebra still. We just need to show how we're now going to turn that into 13 over 30. So as there's a decimal on the top, I need to times the top and bottom by 10. So I'll times the top and bottom by 10. We get 39 over 90. We're almost there. Hopefully you can see how we get there, and you can use this as a little bit of a hint as to how to get there. You can see 30 on the bottom, so we know we need to divide by 3. And when we divide by 3, 39 becomes 13 and 90 becomes 30. So we go 13 over 30 is our final answer. So this bit of working out I did here, timesing by 10, dividing by 3, that's very important because that's part of the proof. We've proved and we've shown how we've actually manipulated that fraction to get the one that we were looking for. So there we go, that's recurring decimals. Let's have a look at our next one. Okay, so the diagram shows a right angled triangle. We've got algebraic lengths. The area of the triangle is 27.5. That's not too bad because this is the base and height, depending on which way you look at it, those perpendicular lengths. Work out the length of the shortest side you must show your working. Well, straight away we know that this x minus 2 is going to have to be our shortest side, because any value of x there, that's going to be smaller. So when we get our value of x, we want to substitute it into that value there. But how do we actually get to that point? Well, for this type of triangle, we just do half base times height. So we just write half base times height, or half BH, so that is the area. So the area equals half base times height. So it tells us the area is 27.5. So 27.5 equals a half multiplied by the base times the height. So x minus 2 multiplied by x plus 4. There we go. Now straight away I can already see it's going to be awkward with a half in there, so I want to times both sides by 2. That's going to get rid of the half, and then we can just worry about the actual double brackets and figuring out what we're going to do here. The fact that we're going to have to expand double brackets and solve this, we already know hopefully, we're going to have to solve a quadratic equation. It's going to involve making it equal 0 and factorising to get our solution, stuff like that. So times both sides by 2, 27.5 turns into 55. So 55 equals x minus 2x plus 4. I do want to now expand that. I'd probably expand that to the side because I tend to expand like in quite a quick method. So I'll probably show the full working out to the side. But x times x is x squared. I do the middle two bits in my head. So x times 4 is 4x minus 2x. So 4x minus 2x is plus 2x. Okay, bearing in mind I have skipped a little step there, so I'll probably do the working out to the side if you're not super confident with that method. And then negative 2 times 4 is negative 8. There we go. So we've got our quadratic. You could write equals 55 on the other side if you prefer as well. So I'll swap it over on this next step. Actually, I'll leave it how it is. We're going to minus 55. So 0 equals, I'll write down that step there, minus 55. So 0 equals x squared plus 2x. And we've got negative 8 take away 55. That's negative 63. Okay, so just be very careful with that. Now I need to factorise what's on the right hand side. Now it equals 0. So that's going to be a double bracket with an x in both. And 63 is, let's have a think. I think it's going to be 9 and 7. So 9 times 7 is 63. You can make 2 out of that. So that'd be plus 9 and take away 7. So x will equal negative 9. And x will have to equal positive 7. So thinking about this here, can we have negative 9? Because you normally can't have the negative values in either of these. So negative 9 on the left there would equal, no, that would equal negative 11. It wouldn't even work in the length either. So our value of x has to be the positive version here. It's not always the positive version, but it is in this one. It usually is. So x is equal to 7. So now we know that x is 7. If we substitute x equals 7 into this side, we get 7 take away 2. Which is 5. Just be careful, do check it in the other one. But obviously you can see if you sub 7 in there, you get 7 plus 4, which is obviously more than 5, it's 11. So our shortest side is the 5. So our final answer here, it's given us centimetres, so 5 on our dotted line for our shortest side. So there we go, that was a relatively tough question there. Obviously forming and solving a quadratic equation using area of a triangle. And yeah, definitely not the nicest of questions. Okay, so on to this one. Carol runs a race. The speed, graph showed her speed in meters per second, t seconds after the start of the race. And we've got a curve. Calculate an estimate for the gradient when t equals 4. You must show how you get your answer. So t is 4 is just here. I've actually seen this question before. So we need to draw a tangent at that point. This is really awkward to do on a screen, but I'm going to try and draw it as best I can. So I always put my ruler underneath the curve. And I want my tangent to just touch it at that point and carry on. Now, I've not done that perfectly, but you'll be able to get that a lot more perfect when you have your ruler out and you do it really carefully. The important part is you want this little gap here to be around about the same as this little gap here, about the same distance away. So just check on that. Try and get it as perfect as you can. It helps a lot if you have a see-through ruler, you know, just so you can actually see the curve underneath your ruler. But it's not essential, but does help. Now, the scale on the bottom goes up in 1 or 2, so I could draw a triangle on here that has a run of 1 or a run of 2, fine either way. So I want to make my triangle nice in line with some of these numbers. Now, last time I did this question I did do a run of 1, so I'm going to do it a bit different. I'm going to do a run of 2 this time, maybe a bit more accurate. So I'm going to go up from there. Right, so carry on up, I'll go across from that point there. So there's my triangle. Get rid of these lines below. So there is my triangle. I have a run of 2. Obviously you can imagine, because we're going to do change in y over change in x, it is easier to have a run of 1, but it can be a little bit harder to read sometimes if it's a tiny little triangle. So I'll go for a run of 2 and we'll see how we get on. The height there goes from, and I need to read this very carefully, so that is again, and that's 5 in the middle, being careful of the scale there, so that's 5.6, and it goes up to one line after the 8, so that's 8.2. So 8.2 take away 5.6. I already wish that I'd done a run of 1, to be honest. It would have been a lot easier, because now I've got to work this out and divide it by 2. So 5.6, that goes 6, 7, 8, 2.2, 2. Plus another 0.4, 2.6. So the change in y over change in x, let's work this out. Change in y over change in x. I've already forgotten that number now. Oh, that's awful. Change in x is 2. Let's go back up and find that again. What was it? 2.6? Yeah, 0.6 would make it 6.2. So 2.6. So 2.6 divided by 2. And that's not too bad, to be fair. 2.6 divided by 2 is just 1.3. So I'm going to write that down just here. And then let's write that on the dotted line. So 1.3 is our gradient of the curve at t equals 4. There we go. So that is finding the gradient. Describe fully what your answer to part A represents. Okay, that word fully is annoying, and that's why we're getting 2 marks for that. So describing that fully. So that represents, I'm going to write this kind of shorthand, it represents acceleration. There we go. That's always the case when we're looking at a speed time graph and getting the gradient, because any gradient to any gradient of the tangent at a curve like this represents the rate of change. So let's imagine it was about volume. It might be the speed at which something fills up per second, something like that. But when it's the change of speed over time, that's quite literally is acceleration. So that's acceleration at the time when t equals 4. And how do we measure that? We measure it in meters per second. So measured in meters per second squared. I think I just said meters per second, it's meters per second squared. So measured in meters per second squared, you can write that as m/s squared. You can also write that as ms to the minus 2, means the same thing. That negative power is just 1 over 2. So it's m over s squared. Okay, that's what that negative power of s means when it's minus 2. So you could write that either way there, but acceleration at t equals 4 measured in meters per second squared. So there we go. That's how we would go about working out a tangent to a curve. And I can already tell here we're now getting onto these harder questions that are just going to take a little bit longer for me to explain. So I will try not to go too quick, but as I said at the start, we're going relatively quick here, as this is quite a last minute sort of revision video. Right, okay, another question I've seen before, so I'm quite glad about that. So let's have a look. So we've got the equation of line L, x plus 2y equals 12. So that's this one here. So we have x plus 2y equals 12. I want to make that y equals to start with. That's the first thing that pops out. So A and D are on the straight line M, which we can see over there. AE is equal to EB. So E is the midpoint, so those two are equal. And E is the midpoint of that, and find an equation for M. So M, you can see as this is a rectangle, M is perpendicular to line L. So straight away, if I rearrange this line equation here to be y equals, I can do my negative reciprocal to get the gradient of M. So let's rearrange that. So we have 2y equals negative x add 12, divide by 2, y equals negative a half x add 6. So the gradient of L, I'll write this here, m equals minus a half. So the negative reciprocal for m, which I'll write as mp, the perpendicular gradient, is going to be positive 2. So that's some information we need. We've also found out by rearranging that the y-intercept here is 6. Okay, and how's that going to help us? Well, if those two lines there are equal distance and E is the midpoint, then to find this coordinate here where they intersect, so we can have a coordinate to put into our line equation for M, we can follow a bit of a pattern. So we can go backwards and up, and then backwards again and up to get to that point just there. So in order to do that, we also need to know this coordinate here at B. So to find that coordinate there, if we substitute y equals 0 into our equation, then we can actually solve that. Now you can actually sub that into the equation we created here, or you could sub it into the original equation. Now last time I did this question, I actually subbed it into the equation we made, but if I sub it into this one, it's actually a bit easier. So if y is 0, you get x plus 2 lots of 0, so x plus 0 equals 12, and therefore x must equal 12. So that's actually probably a quicker way of doing that. Just spotted it as I was looking at it then, so that's 12 there. So therefore, to get to point E, we've had to go minus 12 to the left plus 6. We'd have to do the same here, so minus 12 plus 6. So that right there is the coordinate 0, 6 at point E. So to get to point A, minusing 12 from 0 would be minus 12. Make sure I put the minus in. And adding 6 to 6 would get us to positive 12. So there we go. That's a coordinate on the point on the line M. So if we put all of those into the equation of a line, we would have y equals 2x plus c, and then we want to substitute this coordinate in, minus 12, 12, so we get 12 equals 2 times negative 12, add c, that's negative 24. If we add that over, we get 36 equals c. Again, you can expand that bracket there if you want to get negative 24 and then add it over, but we've got c is equal to 36. So put all those pieces into place. We've got y equals, we know the gradient was 2, so 2x. We've just worked out the y-intercept is 36, so 36, and there is the equation of the line. If you think about it, that makes sense as well, because if we were to extend this line and m was to carry on going up, it is going to hit it up there pretty high, so that would make sense that our y-intercept was 36. So y equals 2x plus 36, let's write that on the final line. Y equals 2x plus 36. There we go, there's our final answer. Okay, these algebraic fraction questions are really not very nice at all. Now, just looking at it straight away, remember when you're doing adding and subtracting, you do that from left to right. So the first two is the two that we have to start with, so effectively we could kind of put a little bracket around those two there, these little squared brackets, which is easier to fit that in. So let's do that. It says show that it can be written in the form ax plus b over x squared minus 9. Okay, that's quite interesting. It's given us the actual full denominator there. Where a and b are integers, work out the value of a and b. All right, so I don't just need the answer, I need to actually say what a and b are, so let's highlight that. So 2, take away that, so I'm going to write that as a fraction. 2 over 1, take away x plus 2 over x minus 3. So I need to make a common denominator, so I'm going to times the left-hand side by x minus 3, so let's just write that there, times this side by x minus 3. So times the top by that, and you could write that as a single bracket as you if you want, but you get 2x minus 6 over x minus 3. And we're going to take away x plus 2 over x minus 3. The fact that it's all takeaways really isn't nice as well, because you'll be very careful when you're doing taking away with algebraic fractions. So on the top you have 2x take away 1x, that's easy enough. So that's 1x. And then you also have negative 6 take away 2. So you've got to be careful there because we're taking away that 2. So that's going to be negative 8. And that's all over x minus 3. So we've got a few marks here because we've figured out the first two, but now we have to take away that final fraction. So take away x minus 6 over x plus 3. Right. At this point, we should be confident we're kind of going in the right direction, because those two denominators are going to make x squared minus 9. You have that difference of 2 squares there. So let's have a look. So let's write that down. So we have x minus 8 over x minus 3, and we need to take away that fraction up there, which is x minus 6 over x plus 3. Okay, so let's work that out. So we need to make a common denominator again. So we're going to times this side by the x plus 3. So times x plus 3. And we're going to times the right hand side by x minus 3. Now obviously I'm going to skip my steps here when I do my double brackets. So I'm going to times the numerator by x plus 3. In fact, I'll write it all out. Let's write it out first. So x minus 8 times x plus 3. And that's going to be all over the double bracket x minus 3 times x plus 3, which is just x squared minus 9. That's that difference of 2 squares. I'm confident enough to just write that in. So then we've got on the right x minus 6 times x minus 3. And that is all over the same double bracket, x squared minus 9. And then we need to expand them. So expanding the left, this is where I'm going to skip steps again. So x times x is x squared. Then I get plus 3x minus 8x, which is minus 5x. Minus 8 times 3 is minus 24. I've got to be very careful that I don't make a mistake while I'm skipping steps, so I don't necessarily advise that unless you're super confident with expanding double brackets in your head. Then take away, we've got x squared, minus 3x minus 6x is minus 9x, and then negative 6 times negative 3 is positive 18, and that's all over x squared minus 9. Again, I've got to be very careful because I've got a takeaway. So I've got x squared take away x squared. So that's going to disappear, effectively just kind of cancelling those out. We also have negative 5x take away negative 9x. So be careful with that. Negative 5x take away negative 9x. That's going to add 9x. So negative 5x add 9x would be 4x. We have negative 24 take away 18, take away positive 18. So negative 24 take away 18 is minus 42, and that's all over x squared minus 9. Right, so I've fully simplified it. Let's just go back to what it said. It should show that it can be in the form ax plus b on the top. We've got 4x minus 42 and x squared minus 9 on the bottom. So what are our values of a? So it did say ax plus b. I don't let that throw you, the fact that we have a minus. Okay, that's absolutely fine. It just means that that value of b is actually a negative value. That's quite common for that to happen as well. So a is in front of x, which is 4. So a is 4, and b is just going to be negative 42, as we've obviously got that symbol changing there. So there we go. There are our values of a and b. Okay, on to our next one. Okay, so we have area of a sector. We've got algebra involved, and we're not using a calculator. And fortunately, this is a question I've seen before because this isn't a very nice question as well. So the diagram shows two shaded shapes A and B. A is formed by removing a sector of circle with radius, and it does show us that in the diagram, so that's fine. Shape B is this circle with diameter 2 minus 2x. Okay, it says the area of shape A is equal to the area of shape B. So we're only looking at these two shaded areas, so that is equal to that. So it's literally just this kind of shaded part here, which is equal to the full circle. Okay, so we need to find the area of both. Now this circle here is definitely the easier one to get the area of, but it has given us the diameter, so we need to write down the radius. So that half of the diameter is 1 minus 1x, so 1 minus x. So to work out the area of the circle, pi r squared, so pi multiplied by 1 minus x squared. You could either write that squared or just straight away write that as a double bracket, completely up to you. So you could write those first as pi 1 minus x squared. So if we expand that, we get pi, 1 times 1 is 1, minus 1x is minus 2x, and then negative x times negative x is plus x squared. And if you want, you could actually rearrange that to look more like a quadratic. So you could say pi, obviously a quadratic that you're used to, put the x squared at the start, minus 2x, and then incorporate the 1 because it's a positive 1. And that looks a little bit nice. So you don't have to do that, but just something you can think about. So for the sector, which is definitely the harder part here, first let's think about this angle of 45. So that's 45 out of 360 degrees if it was a full circle. That is actually simplified down to 1 over 8. So you might know that 90 out of 360 is a quarter, so it's half of a quarter, which is an eighth. Otherwise, you just need to simplify that down. So no matter what angle that you get there, if it's on a non-calculator paper, it's going to be one that simplifies down to a nice fraction. Or a relatively nice fraction anyway. 1/8 isn't great, but it does simplify down, which is a lot nicer than having to deal with 45 over 360 or I don't know, something different to that. So we've got 1/8 of the circle. So the big shape, and as with any shaded shape, we want the, I'm going to highlight this because this is one of our areas, we want the area of the large part of the sector, and we're going to take away the smaller sector. So for the large sector, let's just write down large sector. So we would do the full radius, so pi r squared, so pi times the large radius, which was 5x minus 1 squared, so 5x minus 1, in fact I'm going to write that straight away as a double bracket rather than squared, so 5x minus 1, and for the smaller area, let's write that over here, we have pi multiplied by 3x minus 1 squared pi r squared. So I'm just going to write that as 3x minus 1 in a double bracket straight away. Okay, so to get the shaded area, we need to take them away from one another. Then we'll worry about incorporating that 1/8 as well. That's going to be important. But we'll find the the area as if it was a full circle to start with. So expanding these double brackets, we've got pi, 5x times 5x is 25x squared, 5x times minus 1 is minus 5x, another minus 5x, so minus 10x, negative 1 times negative 1 is positive 1, and we're going to take away pi lots of 3x times 3x is 9x squared, minus 3x would be minus 6x, and then plus 1. And again, you can obviously expand those double brackets a bit slower. I've done that a little bit quicker there. Okay, so if we were to take these away from one another, let's take away those, the part of the bracket. So we'd have pi lots of 25x squared, take away 9x squared is 16x squared. Negative 10x, take away negative 6x. We've got this negative again. That's not very nice. Negative, take away negative 6x. So that adds 6x. That's minus 4x. And we have 1 take away 1. Okay, so that's disappeared. So that's done. Okay, so that is the area of the shaded part if it was a full circle. So now I'm going to reincorporate that 1/8 because we're only looking at 1/8 of that. So let's bring that back in. So we'll say 1/8 of that. And that's what's going to be equal to the other circle that we worked out. So pi lots of x squared minus 2x plus 1. Okay, so obviously not very nice already up to this point. We must be getting relatively close to the end because this is a pretty tough question. So divide both sides by pi, and we would have 1/8. I should probably write that in here, show what I've done. So divide by pi. So we'd have 1/8, 16x squared minus 4x. We've got nothing on the outside of the bracket on the right now, so I can get rid of that. So x squared minus 2x plus 1. You know, two things that you could do here. You could expand this by 1/8, but you are going to get decimals involved or fractions involved when you divide 4 by 1/8. So best thing we can do now is just to times both sides by 8 to remove the fraction. And that's going to give us 16x squared minus 4x, just removing that 1/8. And this side's going to get multiplied by 8. So that'd be 8x squared minus 16x plus 8. Okay, so we have another quadratic to solve. So minus 8x squared from both sides, we'd have 8x squared. Add 16x to the other side, so add that to negative 4x, that would be plus 12x. Double check that, 12 add 4 is 16, so that's fine. And then minus 8, and that's now going to equal 0. So I've moved everything from the right hand side to the other side of minus 8x squared, added 16x, and minus 8. Now I need to factorise and solve this. They all divide by 4, so we could simplify it. So we simplify it first. So that is 2x squared. Add 3x minus 2 equals 0. And then we want to factorise that. I'm definitely running out of space here. So in our brackets, we'd have 2x and 1x. And our only two numbers could be 2 and 1. We're trying to make 3, so I want to double the 2 and the 1. So 2 times 2x would be 4x with a plus, take away 1x. So there we go, that's going to give us 3x in the middle. So we have two solutions there. In our first bracket, we have x can equal 1 over 2, positive a half, or x can equal negative 2. Okay, so the question only actually wanted us to find the value of x. I got a bit carried away there. So find the value of x is our thing here. Must show you're working. We've definitely done that because we've got a lot of work in here. Now, can the x value be negative 2 or can it be a half? Let's have a look. So up here, well, this side here, 2x stands out to me. That could not be a negative value because 2 times any negative number is going to be a negative length. So the final answer has to be x is equal to 1/2 and it can't be the negative 2. Right, so there we go. There is a bit of circle sectors non-calculator involving some equations as well. Okay, let's see what we got. Okay, the vectors question, right. Wouldn't be complete without a vectors question, would it? Right, so OABC is a parallelogram. O to A is A, that's on the diagram. O to C is C. X is the midpoint of the line AC. Okay, so that line actually hasn't been drawn in, so we want to draw that in ourselves. So X is the midpoint. So let's just put a little dot there, call that X. If it's a midpoint, I always put the fractions, so half and half, okay. OCD is a straight line, so the O to C, C to D is K to 1. Okay, so O to C, C to D, we don't have a D anywhere, so we're going to have to extend that. So D is, I don't know, somewhere there. Let's just say it's here. Okay, let's label that as D. Just be careful, because the way that I've drawn that, it does make O to C look longer than C to D, but remember we don't actually know the length of that. So don't assume that it's shorter or longer just by the way you've drawn it. It says given that x to D is 3c minus half a, find the value of k. So x to D, let's draw that in. So from x to D in that direction is 3c minus a half a. Find the value of k. So can we get from x to D in a different way? Because it's told us that x to D is 3c minus a half a along that straight green line there. So can we move that way a different way? Well, we could go from x to c and then from c to d. One thing we do know about c to d is it's going to have to be some multiple of c. Whether that be a bigger multiple or a smaller multiple, we don't know. It could be like a half of c, it could be 2/5 of c, it could be 5c, it could be anything. So we've got to try and actually work that out. So let's actually have a look. So how do I get from x to c? Well, to get from x to c, I need to know a to c. So let's work that out. So a to c, and that is, and you can write this in two ways, because I can go minus a plus c, or I can write it as plus c minus a. Now I always tend to write it as plus c minus a. So I'll write it as c minus a. You can write it the other way around if you want, that's fine. So from x to c, it's going to be half of that. So x to c will be half of c minus a. As it's a midpoint, we're only moving halfway along the line. So that is a half c minus a half a. I actually think this is going to be the worst vector question. This isn't too bad. Obviously there's much harder ones than this, but it does involve a bit of ratio, so it looks like it's going to be harder than it is. So we'll wait and see. Maybe that'll be my last words. Maybe it will be a little bit harder than I'm thinking. So from x to d, we've already been told that's 3c minus a half a. But if we're going from x to d, we've already got from x to c, but to get from c to d, and let's just rub out this arrow here, we know it's going to be a certain amount of c, but we don't know how much. So let's call that any letter here. I'm going to use the letter x, but I don't want to get that confused with the point x. Let's just call that x lots of c. Okay, basically an unknown amount of c. You can use any letter. You could use it. I was going to use k, but that's also in the question as well. So I'm going to avoid that. I'm just going to use the letter x. So from x to d, on our end, that would be from x to c, which we've just worked out, a half c minus a half a. And we're going to add to that a certain amount of c that we don't know. But what we do know is that it has to match this vector here. So it has to match 3c minus a half a. So let's write that out. So we know a half c minus a half a plus a certain amount of c has to be equal to 3c minus a half a. So 3c minus a half a. So how do these compare? Well, let's look at the a's. So we have minus a half a, and that matches minus a half a, so that's good. Okay, we're probably onto the right track here. But what we have is a half c here and an x, and that's got to equal 3. So those two numbers there have to equal 3. Now you might just be able to do that in your head, to be fair, but essentially we have a half plus x has to equal 3. And you can probably spot there that that's going to be 2.5. So x has to equal 2.5. I'm going to write that as a improper fraction. So that's 5 over 2. So that equals 5 over 2. I tend to just deal with improper fractions when I'm looking at vectors, just because of when you have to add them together and stuff like that. It just makes things a bit easier. So we know that x is 5 over 2. So straight away, we know we can replace that x lots of c. We can say that that's 5 over 2c, or 2.5c. So there we go. As it turned out, actually, that line will be much longer than the way we've drawn it, which is why I always think don't rely on your own diagrams too much there when you're just drawing a sketch. So the question actually wants us to find the ratio O to C, C to D. Well, O to C is 1c, and C to D is 5 over 2c. So if we write that ratio out at the moment, let's think O to C, C to D is 1 to 5 over 2. It was 5 over 2, double check, so 1 and 5 over 2. And we want it to be in the ratio k to 1, to give it asked in the question there. So how are we going to make 5 over 2 become 1? Well, we'll divide it by 5 over 2. and that means we have to divide the other side by 5 over 2 as well. There we go. So that's going to definitely give us 1 on the left, but we just need to work out, sorry, 1 on the right. We need to work out what that's going to be on the left. So 1 divided by 5 over 2 is the same as 1 multiplied by 2 over 5. And 1 times 2 over 5 is 2. I'm sure I said 2 over 5 at some point as well for something different. But 1 times 2 over 5, there we go. That's going to be 2 over 5. So k, that number on the left of the ratio, is going to be 2 over 5. Right, so there we go. That wasn't actually too bad. It was still comparing coefficients of vectors. It had ratios involved, and we had that horrible last step there by having to write it as a ratio and do some division of fractions, but that wasn't actually too bad. That's quite a nice entry question into sort of comparing coefficients of ratios, actually. Obviously, those of you that have done quite a few ratios will know that there are some pretty nasty versions, but that was actually like an okay one. It's still very high-end grade 9, but it was okay. Okay, we've got another question as well. Let's just have a quick look. Oh, so this is our last question. Okay, so last question, and this is equation of a tangent to a circle, and the coordinate is also in surds. Right. I have seen this question, but I haven't done this one in quite a long time, so let's have a look. So L is the circle with equation x squared plus y squared equals 4. P is the point 3 over 2 root 7 over 2, and that is on L, is a point on L, so the circle. Find an equation of the tangent to L at the point P. Well, straight away, whenever we have a tangent to a circle question, I always draw a sketch of a circle, so I can visualize it, and that wasn't too bad of a circle there. And I'm going to think where that coordinate goes. So that is in the positive quadrant just there. So my tangent is going to go down there. So that point is point P, and that is the coordinate 3 over 2 and root 7 over 2. So I need to find the gradient of the radius, which goes from 0, 0 up to point P. So the gradient of the radius, let's just write that down. The radius, m, is equal to the change in y over change in x. Now the change in y over change in x for this, because they are fractional coordinates, I'm going to write this differently. I'm going to write the change in y divided by the change in x. That's just what that fraction means anyway. So the change in y goes from 0 to root 7 over 2. So we have root 7 over 2 divided by the change in x, which goes from 0 to 3 over 2. So we've got lots of dividing fractions. So when we're dividing fractions, I'm going to keep flip change. So root 7 over 2 multiplied by 2 over 3. And that equals 2 root 7 over 6, which obviously simplifies. We could have cross-cancelled those 2's. Divide the top and bottom by 2, you get root 7 over 3. So that is the gradient of the radius. So for the tangent, we're going to want to do our negative reciprocal, as the tangent is perpendicular to the radius. So the perpendicular gradient is negative 3 over root 7, just swapping that over. So there we go, not very nice, but there is the gradient of the tangent. So that is going to need to go into y equals mx plus c. So y equals minus 3 over root 7x plus c. And now we need to substitute the coordinate in that it passes through, and it passes through 3 over 2 and root 7 over 2. So if I sub that in, sub the y coordinate in first, so root 7 over 2 equals negative 3 over root 7 multiplied by the x coordinate 3 over 2 plus c. We need to multiply those, so root 7 over 2 equals negative 3 times 3 is 9 over 2 root 7, okay, plus c. So to find a value of c, I need to add 9 over 2 root 7 onto the root 7 over 2. So root 7 over 2 add 9 over 2 root 7 is going to equal c. Okay, so I've just got to work that out. It's not actually too bad. I've just got to multiply the left fraction, top and bottom, by root 7. That's going to give me a common denominator of 2 root 7. So if we do that, let's have a look. So root 7 times root 7 is 7. On the bottom, 2 times root 7 is 2 root 7. add 9 over 2 root 7, and that equals 16 over 2 root 7. I don't think you necessarily have to simplify this, but they do actually both divide by 2, so I'd probably write that as 8 over root 7 as well, just to simplify that. But there we go, there is our value of c. So we have our gradient, and we've got our value of c, so we've actually got everything we need. So y equals, what was the gradient again? Negative 3 over root 7, so negative 3 over root 7 x plus the value of c, which is 8 over root 7, and that's our final answer there. There we go, that is in the form y equals mx plus c, so you could write that slightly differently as well. I mean, you could write 8 over root 7 minus 3 over root 7x, that's fine. If you want to reduce the amount of symbols, you could rearrange it into different forms as well, but that is our final answer, and that is the final question. There we go. So that was quite a stretch. I'm not sure exactly how long that's taken me, but yeah, there's quite a lot of tricky stuff in there. So you've got to be very careful when you're going through these sorts of things. Obviously, don't rush any of the questions, particularly those ones at the start, because as you've seen, these questions at the end, I mean, that question there, look, it's only worth 3 marks. And there was a lot more working in that question and a lot more knowledge than 3 marks that you'd have to pick up on some of those earlier questions like product of prime factors at the start. So you want to really make sure that you're super careful on those questions at the start, because these questions at the end, you have to do a lot more work to actually pick up those marks. So there we go, that was the end of the paper. Hopefully that was useful and helpful. I will link all the topics in the description. So if this is the last night before your exam, all of those lessons are going to be there, and they're all there for you to check. I'm also going to link through all of the videos that I've just done recently. So I've done, I think, six videos looking at difficult versions of questions. Some of them actually came up in this video here, but you can always check them out. I also did a video looking at 5 of the hardest topics to come up on this paper 1 GCSE as well, and there's another video going over 10 difficult questions, and that has a really nasty exact values of trigonometry question in that video as well. So make sure you check all of those out. Hopefully this was useful and helpful. If it was, please don't forget to like, don't forget to comment, don't forget to subscribe, and best of luck in your exam. Please do let me know how you get on. Okay, but that's the end, and I'll see you for the next one, where we're going to be looking at all the paper 2 topics. Okay, so best of luck in your exam. I'll see you for the next one.